Well, welcome to Demo Day for the second class of the Rice Alliance Clean Energy Accelerator. It is so great seeing so many of our community friends here today. I see lots of familiar faces. I see lots of speakers and mentors in the audience. It means a lot to us that you are here, and we are super appreciative that you took the time to do it. The beer and wine afterwards might have convinced you also, so we're happy that that's happening. We appreciate you being a part of this celebration and sharing in the promise of all of these companies. My name is Carrie Smith, and I am the Executive Director of the Clean Energy Accelerator. Today, you will hear from these 17 companies that have just completed our 10-week program. Our primary goal, among others, is to connect you with them and feature them in a way that you can learn more about their investment and partnering opportunities. Once they've all pitched today, please stick around for the showcase afterwards, and you can visit with them one-on-one and ask your questions and share a cheese cube and a glass of wine. Some of you who attended the Energy Technology Venture Forum back in September may have met some of our founders when we launched back in September. And we saw in this group enormous potential and designed a curated program that tried to meet them at their developmental stage. We also tried to help them achieve some near-term objectives. Today is a culmination of that work over the last 10 weeks and showcases what they've accomplished in that short time. And we're super excited for you to meet them. So serving multiple energy sectors and representing headquarters spanning across the United States, Canada, Israel, and England, this year's class brought forward a mix of diverse energy transition solutions. Collectively, they are driving innovation in advanced materials, digital technologies, energy efficiencies, energy storage, waste heat to power, wave energy, and wind energy. Collectively, they came into the program having already raised roughly $55 million. And over the last few weeks, several of them have closed on new rounds, bringing the cumulative total amount raised to a little over $61 million now. Is that right? Congratulations. Thank you. Mitru, is that you? Yay, thank you so much. But before we get started with our pitches, I would like to acknowledge and thank a number of people and organizations with whom we've collaborated in order to build out this program. The support of Wells Fargo and all of our other supporting organizations have helped us build out our vision and offer this unique opportunity to these emerging ventures. We appreciate their early involvement and look forward to continuing our collaborations in ways that result in meaningful impact. To our energy sponsors, since the early days of the Rice Alliance, we have benefited from relationships with nearly all of these organizations. They have supported our programming, and they've provided integral networks for the hundreds of startups that we've participated in throughout all of the programs over the last 21 years. We appreciate the work that they do in order to bring life to all of our initiatives. To the Energy Advisory Board, thank you for taking my calls, answering my emails, attending my meetings, and accepting my invitations to speak. Your guidance has been instrumental in advancing the work of these founders, and we look forward to developing new opportunities to continue going forward. The speakers are the ones who impart most of the learnings that we deploy over the course of the program. By sharing their been there and done that stories and conveying best practices for staying on the rails and avoiding those inevitable booby traps, these founders can now more easily navigate their own journey. So we appreciate you helping us out. And I invite you to please remember how much fun it was when we reach out to you again next year and invite you to speak. And to our mentors, In addition to making connections and taking meetings, this group spent countless hours with our teams, challenging them with crucial feedback, helping them refine their business models, helping them hone their presentations, all in an attempt to support them in whatever way possible. And to the team that makes the best sausage ever, Matt and Simone and I would like to make sure you know how much we appreciate all you've done in order to make this day possible. This gifted collection of leaders have worked alongside our founders, delivering essential guidance and providing support that has helped inch our founders closer to their milestones. The executives in residence, Mike, Fatima, Deanna, Stephen, Nathan, leveraging your industry knowledge, your expertise, and your network by working one-on-one with our founders to help them overcome their day-to-day challenges and help them navigate those inevitable obstacles that pop up. Your contributions have fundamentally impacted the ways that our teams achieve success. So I want to personally thank you for your commitment not only to this program and this accelerator, but also to advancing solutions that help position Houston as a leader in the energy transition. I want to also, you will hear also from our XIRs as we go forward in the program when they introduce each of the pods with whom they worked. And to the Rice Alliance team, the ease with which you all block and tackle is dazzling to me. We appreciate all of the heavy lifting that you all have done and the combined forces that you have provided us throughout the program. So thank you to the Rice Alliance team for all you do as well. So the way this works today, we're going to jump right into the format of today's activities. Over the next 90 minutes, we will spotlight each of our 17 companies. They'll have roughly 4 minutes to pitch back to back and grouped by their pod. So there is no Q&A during this portion of the event, but we do ask that you table your questions for later over the showcase when you stick around. So each of our 5 XIRs will present the companies in their pod, and we will be beginning with Fatima Bello's pod. And so Fatima, if you are ready, wherever you are, please join me in the welcome at the podium, and join me in welcoming Fatima.
Oh, thank you, Carrie. So working with your team and the rest of the Rice Alliance team this past quarter has been awesome. Learned a lot. It's been a true privilege working with each one of my team. I think my pod is the very best pod, but I bet to differ. So presenting my truly global pod of 4 amazing companies, experienced team of founders with truly transformational clean hardware and software technologies. From energy storage, new engine technologies, all the way to carbon accounting. Really excited. These guys are going places. So starting off with Lina Energy. Lina is a sodium-ion battery tech company. Having just closed a $4 million late seed raise. They're not slowing down as they move forward with commercializing this truly disruptive sodium-ion battery technology. Next, Atagis Energy, ocean wave engine technology company. Yes, that ocean wave. Now redesigned and heading towards CRL6. Really excited for these folks. They're on their way to raising a seed capital. Luminescent, liquid-based isothermal engine technology, all the way from Israel. Upcycling waste heat with its really highly efficient engine. They're raising Series A in the next quarter. And finally, Emission Critical, Eastern Favorite. This integrated carbon management company offers a unique model for carbon accounting and reporting. They're also raising a seed round. So without further ado, we'll talk. Lina Energy.
No pressure going first, eh? So hello. my name's Will. I am the Chief Commercial Officer at Lena Energy. And Lena Energy are commercializing these solid-state sodium batteries. They contain no lithium and no cobalt. And why we're doing that is we can offer 4 key advantages to our customers over incumbent technologies. We can offer cost benefits, savings of over 50% at both the CapEx and levelized basis. We offer higher energy capacity, and our batteries work great even in high temperatures. We are a more sustainable battery. These are made of abundant raw materials, and they have a lower embedded carbon. And they are inherently safe. These things do not catch fire. Lena Energy's innovation is the combination of a proven but forgotten 1980s sodium metal chloride chemistry with advancements and modern ceramics developed out of the fuel cell industry. If you look inside one of these battery cells, in its core is a sodium conducting ceramic. We're using that as our electrolyte instead of a traditional liquid solvent. That reduces the ionic resistance of the cell, but also the mass, and that's what underscores our performance. We're differentiated by the fact that we're using a proven chemistry. This enables us to save years from avoiding being in the lab, doing fundamental chemistry set discovery and electrode design. Instead, we get to focus on product development and engineering, accelerating our route to market whilst building a healthy portfolio of IP. We've got 11 granted patents and 14 pending. This is the team. There's 30 of us. We're based in the UK in a little town called Lancaster. It's just shy of the Scottish border. Rains a lot. And our leadership team is a combination of technical expertise from the fuel cell, materials science, and battery industry, combined with financial and commercial expertise from investment banking, consultancy, and, of course, oil and gas. We've been busy over the past few years, and we've got to a point now where these cells not only match the energy density of lithium ion, they exceed it. And having done that, I want you to remember one thing today about Lena Energy, and that is that we are not a concept. We have taken this from the lab, and we've built and tested over 1,600 cells, and we've demonstrated full battery systems at a kilowatt-hour scale. And now we're ready to move from competitive to disruptive, and to do that, we need to build bigger systems. So this is our MVP, our minimum viable product, a 10 to 20 kilowatt-hour energy storage system, and this is key to our route to market strategy. So we know energy storage and batteries is a huge mammoth industry and market here, right? So navigating it is key. We've identified microgrids as our beachhead market, and that's where we will commercialize that MVP, but we can scale all the way up to bigger grid-scale markets whilst keeping the fundamental technology and the IP in here the same. And we have commercial agreements and partnerships in place with those beachhead customers in the UK. We're also doing real exciting things out in India. So we're developing our product via the CEIIC, which is in Tata Power Smart Grid Labs in Rohini, Delhi. We're taking a unique approach to manufacturing as well. So we are using methods that are new to the battery industry, but are proven in the PCB and food industry. And by leveraging existing industry know-how and infrastructure, we can scale our own business capital efficiently. So today, we've been financed via a 13 million rounds of private equity and $3 million of non-dilutive grants. We're now here because I'm preparing a $20 million Series A for next year. We want to use that money to automate our critical manufacturing processes, to build bigger systems and more systems with our customers, and to blueprint our pilot manufacturing line. So thank you so much. More importantly, thank you to the Rice Alliance. What you've done here is really something special. And again, the one thing I wanted you to remember is we are more than a concept. We have lots of cells and we have systems. We're running a system live right now, so you can come to our demo booth, and I'd love to tell you more about Lena Energy. Thank you.
Hi, I'm Bill Hartman, CEO of Atargus Energy. Finally, no kidding, 6 cents per kilowatt hour baseload electricity from ocean waves. Many of you may know that there's a tremendous amount of energy available from ocean waves. In fact, as much as 25% of the world's electricity needs could be met by ocean waves if only we could figure out how to tap it. But you also may know that every technology until now has failed miserably to do that. Failed because they don't produce very much electricity per device, and failed because the electricity they produce simply costs way too much to make any sort of economic sense. This is the Atargus Cyclic. It'll be the first technology to produce predictable 6 cent per kilowatt hour baseload electricity for the $500 billion, that's with a B, billion-dollar ocean wave energy market. We combine a disruptive clean sheet design with our patented hardware and undisclosed control system software to capture 95% of the energy in each and every wave. Each cyclic will be located in 150 to 300 feet of water, operating autonomously well below the ocean surface, out of sight and away from storms. Why are we different? Well, everybody else uses buoyancy and drag forces. We alone in the world use lift. Lift, as we know, going from blimps many years ago to now jet aircraft and hydrofoil racing boats, is much more energy efficient, is faster, and lighter weight. Because our competition does not use lift, they're limited to much less energy conversion per device and therefore much higher costs, 10 to 20 times a Targus's cost. Another key to our being able to capture so much energy per device at such low levelized cost of energy is that Targus alone has our unique proprietary undisclosed control system. Without our control system, all this fabulous hardware that I just described is literally worthless. This means we have extreme limits on our competition and a key to a successful business model. And behind all this has been an incredible team leading the development of our technology, the testing of our technology, and the modeling of our technology, now combined with a growing team of world-class advisors with very deep expertise in things like energy project development and finance, technology development, government policy, and operating in the maritime environment. Here's an example of what one of these farms might look like off the coast of California. This is a 250 megawatt farm, which would be 100 2.5 megawatt cyclics located in 150 feet of water just offshore, producing 460 gigawatt hours of electricity in a year at a cost of 11 cents per kilowatt hour. But I said 6 cents. Okay, 6 cents if you up it to a gigawatt, which isn't really that much deployed, much lower at greater scale. And not only will we be great all by ourselves in standalone wave farms of hundreds of megawatts to gigawatts, we make offshore wind better. We make offshore wind better because we provide critical baseload electricity at a very low levelized cost of energy, in some cases lower than offshore wind, while using the same supply chain, the same infrastructure, same process and permitting that they're already using in offshore wind. Our go-to-market strategy is right now we're going to be testing with our Department of Energy friends under a grant with the Department of Energy and the U.S. Navy, 1 to 15th scale cyclic at a U.S. Navy facility in 2023, and then developing a 1.25 megawatt and a 2.5 megawatt system in 2025 and 2026 respectively, and then moving on to pilot scale by 2028. We'll be working with offshore wind developers both on the development side and the revenue side. And longer term, what we're also doing is looking selectively at opportunities where we could produce and develop and operate our own wave farms. Our current raise is $1 million. That's to leverage a $200,000 grant with Chevron Technology Ventures, $2 million grant we have in place from the Department of Energy, and complete our testing in 2023 and move to an A round in 2024. I want to thank you so much for your opportunity to talk today, particularly to the Rice Alliance for all they've meant for us. Please come upstairs, right up here, and look at a 1/100 scale cyclic that will show you in operation. Thank you very much.
Okay, so my name is Doron Tamir, and I'm the co-founder of Luminescent. For more than a decade, I was the biggest solar energy developer in Israel. My partners was EDF and Total. But I realized that solar energy, even with batteries, it's not the right solution if you want to be serious about energy transition. Not baseload, not dispatchable, not stable. So I sold my company, and I don't have the... okay. So I sold my company, and I realized that 70% of the energy is wasted. But the problem with wasted is that it's a very small project. It's under 10 megawatt, usually under 5 megawatt. So, and the usual or the existing technology, which is a steam turbine and ORC, organic ranking cycle, it's too expensive, inefficient. So actually, in the end of the day, the results, no one or almost no one do waste heat project. And this is exactly the problems that we can succeed to solve. We develop new disruptive heat engines that it's low cost, it's efficient, and it's small. So now actually you can generate zero-emission electricity from any source of heat, especially waste heat. So we have a team of 12 people and a great combination between the academy, leading my partner, Professor Kamel Rothschild, from the Technion. The Technion is the MIT in Israel, or something like this. And Erez Klein, my VP Engineering, that was for many long years, the VP Engineering of Ormat. Ormat is one of the leading ORC companies in the world. So this is our proof of concept. The wide is 1.6 meters, and it's third the cost of any existing technologies. And how we can come to third of the cost, because it sounds unreasonable. And the reason why you can see in the movie, this is our proof of concept, it's one just rotate component with 4 nozzles, and we are liquid-based. We are the first engine that we are liquid-based, which means that actually we are 1,000 times more density, energy density. So the CapEx can go very sharp down. And another thing that we have isothermal expansion, so our efficiency is better. So then now we have efficient better, and the cost of the CapEx, it's lower, much lower. So we have 2 markets. The first one is renewable storage. Actually, with our engine, what we are building, it's Carnot battery, and we have cycle efficiency, round cycle efficiency between 70 to 80%. We work for 30 years. We don't need rare materials, so it's a great solution. But usually what I'm speaking here in this program, it's about a small open cycle gas turbine. Because along the gas pipeline in the US, you have more than 25 gigawatt of a small open cycle gas turbine, between 1 megawatt to 7 megawatt. 70% of the energy is just going to the atmosphere. We can take this waste heat and generate zero-emission electricity. How much? At least 15 gigawatt of zero-emission electricity with very high capacity factor. So on high level, in this year what we've done, we already done our proof of concept, successful one. We have generation 1 of our turbine. We already had our seed round, 7 million. Next year, what we're going to have, it's a commercial pilot with one of the biggest tier 1 companies. We're going to have our new round, A round. In 2025, we're going to have our first commercial, first sales. So we are looking for investment leader for our round A. Our round A is going to start in first Q of next year, and it's going to be 40 million. Thank you very much.
Hello, everyone. My name is Sham Seturam, and I am the CEO and co-founder of Emission Critical. I ran a software consulting firm for more than 8 years, and my energy clients asked me a question. They asked, how can I track carbon in the same way that I track oil, gas, and water? This question intrigued me, so I decided to dive deeper. Reached out to more than 20 companies, and the feedback was overwhelming. They all needed help with something called product carbon footprinting. This is the idea that you take your scope 1, 2, 3 emissions, and you assign them to every product, project, and service that the company produces. I like to draw the analogy of a nutrition label, where you might have your top-level metrics, your net carbon footprint, your shipment size, your emission breakdown, scope 1, 2, 3, all the constituent greenhouse gases, and the mitigation breakdown, any offsets and any credits applied for that specific product. Product carbon footprinting occupies a sort of sweet spot in that it helps companies satisfy their compliance customer reporting. It also helps them focus on their critical path emissions, and it helps them earn premiums on their lower carbon products. Product carbon footprinting, though, is a snapshot in time. And what we really need to do is trace those emissions from where the product was conceived to when it gets exported. My new company, Emission Critical, is a software-as-a-service carbon emissions platform that focuses specifically on product carbon footprint tracing. It has an industry allocation framework and configurable library of formulas to really cut down the time to value for organizations. We also have traceability and controls because carbon data is financial data. And then third, we also have a data estimation model to help with Scope 3 data gaps. At the moment, we are demonstrating our product for an LNG use case. We have plans also to demonstrate it for a refinery use case and a petrochemical complex. We're also working with firms who basically provide verification for these GHG statements. And they've told us that our product will help them provide the highest level of assurance. Now, how do we fit in the overall landscape of carbon accounting solutions? Well, most of the carbon accounting solutions today really focus on the corporate and ESG reporting case. That's really top up through the corporation. We're really focusing on the product level, which needs a set of different software features, and it's a distinct use case. We accumulate our IP really from our proprietary attribution framework, which is all these complex rules about how to assign emissions to each individual product. Our system is fully configurable for all product pathways, and we've embedded industry metrics and translated hundreds of pages of guidance into our product. How does our product actually get more adoption? Well, there's worldwide mandates from securities regulators, from the financial system, and one that we're really keeping an eye on is the carbon border adjustment tax, which is a tax on embedded carbon, and it will have implications for product carbon footprinting. As these mandates get rolled out, they will basically help us expand from our beachhead market, which is energy, into adjacent markets like mining and power. Now, who's the team behind this particular product? Well, we're a team of second-time founders. We have an exit and IPO under our belt, and we have experience doing GHG management projects with leading energy companies. For our milestones right now, we are live with our current product, and we are going to be achieving multi-industry and multi-module within 2 years. We are seeking to expand our use cases and partnerships for pilots, and we are also looking for an investment of $3.5 million to achieve multi-module and multi-industry. Thank you very much. Tracing carbon is mission critical if we want to achieve our climate ambitions today. Please come visit us at our booth. Thank you very much.
Hello, I'm Nathan Ball, one of the 5 XIRs for the RICE CEA program. I'm a serial entrepreneur, have experience in developing and commercializing new products for more than a decade in automotive, consumer electronics, energy storage, and wastewater treatment sectors. I'm really excited about my 4 startups. Listed right here: Quino Energy, GoLeaf, Volta Technique, and Woots. All of these are in the advanced materials, advanced chemical process, or energy storage sectors. All of these startups base their innovations on a fundamental discovery, either in the material level, the chemical process level, or just basic thermodynamics to create something that's really revolutionary and exciting. The first of these, and all of the entrepreneurs are fantastic people also. The first of these, Quino Energy, unfortunately, Eugene Bay was not able to be here because a certain virus disrupted his travel plans and he's stuck at home today. But he has a video presentation he produced himself on his laptop 2 months ago that he'd like to share with you. And then I have a couple of slides to context his asks for the Houston energy community as well. So here, I think, is going to be Eugene's slide coming up, or Eugene's video.
Hi, I'm Eugene, co-founder and CEO of Quino Energy. Now, you've probably heard a lot about going net zero. Well, we need 2 things to decarbonize our electrical grid: renewables and energy storage. We've pretty much figured out solar and wind generation, but there still isn't a cheap and safe enough battery technology for the grid, or for your home for that matter. Quino Energy is commercializing water-based organic flow battery technology licensed from Harvard for homes and grids. We've got a process that can take commercial dyestuff chemicals made from coal tar and petroleum aromatics and convert them directly into high-performance, long-lifetime battery reactants inside the flow battery system itself. Now, the best part? There's no separate chemical factory and 0 chemical waste. This lets us create a battery with a capital cost as low as $65 per kilowatt hour. That's actually half the cost of lithium-ion battery packs. And everything is dissolved in water, so there's 0 fire risk. Quino's technology and process are protected by an exceptionally strong IP portfolio that gives us broad freedom to operate worldwide. We're scaling up fast by producing and using our secret sauce in commercial flow battery systems. In fact, we've already demonstrated pilot scale production together with a partner in Germany. And we've received a non-dilutive $4.6 million grant from the Department of Energy, which will begin next month. We are currently raising a $3.5 million seed round for 30 months of runway. This will allow us to produce and validate half a dozen 24 kilowatt-hour battery systems sized for homes, in addition to a utility-scale prototype that can store 400 kilowatt-hours of energy. Now that's enough to power 20 homes per day. If you're a climate tech investor who wants to be part of this exciting journey, please drop us a message below. Thanks, and let's connect soon.
So Eugene is a pretty impressive person. He's a Harvard guy, he's a Stanford guy. He's fluent in multiple languages, including Mandarin Chinese and Japanese. And their seed round, which they just closed last month, was led by a very active seed investor based in Tokyo, Japan. So impressive story to date. What's really exciting to me as someone who spent 10 years first founding and then leading a battery materials company is that this energy storage play has the potential to run very quickly from seed funding to commercial profitability because of the way his technology is and his system is designed. They've already developed demonstrated pre-seed that the chemistry that was developed at Harvard could be dropped into existing flow battery systems and designs to produce 80 kilowatt hours of power. To context that, that's about 3 houses of power over the course of overnight. Based on this success and the drop-in nature of his solution, as well as the milestones that they continue to achieve this year and in the coming year with seed funding, I think it's entirely plausible that they will be in commercial production and perhaps even profitable within just a few years, which is unheard of for an energy storage materials startup in this space. In addition to that, Eugene has a specific ask for Houston. He was very excited to come to Houston. He's been to Houston several times over the course of this program. He really wants to connect with and work with developers of large-scale energy storage projects, especially if you're looking for lower-cost energy storage solutions than what's out there today. There's a lot of government funding right now flowing to kind of grease the wheels for some of these types of projects that they're trying to plug into as well, but of course any project is one he'd be interested in, as well as connecting with petrochemical manufacturers that could potentially make the naphthalene-derived chemical products that go into his batteries, and of course investors that would be interested to participate and sustain the company through Series A and B rounds in the future. If you're not any of those, or if you're not really interested in doing business with Quino today, we still invite you to visit his LinkedIn page. He has a little bit of a contest right now for a $100 Amazon gift card that helps to drive traffic and engagement with the community. So, but if you are an energy project developer, an energy storage investor, or a petrochemical manufacturer, I think Eugene would be really interested to meet with you. All right? And his, of course, contact information and socials are listed here below. So up next, we have 3 more companies I just want to introduce real briefly. GoLeaf is led by Arshin Alam, who has a very strong technical background. She's also a serial entrepreneur and an inventor. She's invented carbon-based membrane products for water filtration and carbon products for energy storage. We have 2 more entrepreneurs following her, Kamyar Rundej, who spent years as an energy manager for a municipality with hundreds of properties. He wasn't able to find an energy storage solution that worked for his properties, so he developed one at the university in his PhD and has started a company, Volta Technique. He's excited to share with you today. And the third entrepreneur in my pod, or the last entrepreneur in my pod, but certainly not least, is Olivia Espai Huntington. She's a Rice alum, and she left the state to get her JD and then worked for a New York law firm for several years doing M&A and IP transactional or corporate law, but now she came back to Houston recently to co-found a company with some other Rice alum, and she'll be very excited to share what Woots is doing today. So without further ado.
Good afternoon. I am Arshin Alam, founder and CEO of GoLeaf. Prior to GoLeaf, I founded C Nanos, where I was on a quest to find a low-cost water purification solution for underserved communities. At C Nanos, I developed a carbon nanofiltration technology, patented it, and deployed it across India. Since then, I've spent over 10 years in the carbon nano research world, which has led me to graphene and the launch of GoLeaf, where we are making ultra-high power density supercapacitors from carbon waste. And I've been instructed to tell you that this technology has landed us a spot on the Forbes 30 Under 30 energy list. Unlike existing graphene producers who use graphite as their source material, GoLeaf has developed a proprietary and patented process to extract graphene oxide from various carbon waste byproducts, such as waste tires and petroleum coke. Our process is 90% lower cost than existing methods and emits up to 80% less greenhouse gas emissions. This low-cost, eco-friendly graphene production method is enabling breakthroughs in power services and reliability. On the left here, you'll see an image of GoLeaf supercapacitor prototype. This prototype has demonstrated to have more than 2 times the power density of leading supercapacitors on the market today. To put that power density into perspective, a Tesla Model S outputs 500 kilowatts of power. A Ford F-150 electric pickup truck outputs 345 kilowatts. GoLeaf supercapacitor of the same size can output 1,094 kilowatts of power. The supercapacitor market is huge, estimated at $24 billion total market size. We believe we can service about $7 billion of that market, with our supercapacitor being ideal in 3 key product areas: electric trucks and buses, uninterruptible power supply, or UPS, and grid storage for frequency regulation and eliminating unstable power transmission. That being said, supercapacitors are the tip of the iceberg for GoLeaf. GoLeaf's low-cost graphene is a platform technology that opens up market opportunity across industries, ranging from water desalination, paints and coatings, construction materials, and composites. The GoLeaf team consists of material science, civil, environmental, and chemical engineers. Our team has a tremendous amount of experience in business and legal, with several of our members having started and successfully exiting companies in the finance and energy sectors. Up until now, we have developed and optimized our graphene production process on our graphene supercapacitor. Today, we are using our $700,000 Department of Energy grant to automate our graphene production process and are raising $3.5 million, of which $2 million is committed to set up our automated scale-up graphene production facility and develop prismatic and cylindrical cells, which will lead us to our Series A in 2025, when we will raise $15.5 million to set up our supercapacitor manufacturing plant, and we anticipate $24 million in supercapacitor revenue in 2027. Thank you to Rice Alliance and all of our partners who have supported us along the way. We hope you join us. Please come see us at our booth. Thank you.
Good afternoon, everyone. My name is Kamil Rindej, and I'm the founder and CEO of Volta Technique. We are developing the first compressed air energy storage technology built from the ground up in decades. We're able to store electricity at 1/3 of life cycle cost of batteries while providing heating and cooling. To put that in comparison, the picture on this side shows what exists today, and the picture on is what we are building and how compact it is. Before starting Volta, I was an energy manager looking over a portfolio of assets of over 700 buildings, which included water treatment plants, hospitals, and multiple different commercial facilities. And we were looking for a storage solution that addresses the problem that are very typical in terms of cost and reliability for the commercial sector, and I couldn't find one. At the same time, as a PhD student, I was looking and say, okay, maybe I can find a solution for that. So I spent the next 8 years designing a system from Azubah. And we end up with a grid scale technology that has been shrunk down to fit in the space of few parking spots. Now, in terms of the market we are serving, we are fitting between batteries which are meant for about 8 hours or so, or a few hours of service, and large-scale grid systems which go for days. And this is an underserved market. We can provide between few hundred kilowatt power up to a few megawatts of power and going for about 8 to 12 hours span. This market is currently covered with other solutions. None of them are perfect fit, and so we have no direct competitor in that space. In terms of the opportunity, our beachhead market is data centers because they're particularly well suited to take advantage of our cooling capability. Just in North America alone, there are over 3,000 suitable sites. But because of our size and space, we can virtually be deployed anywhere and service many other segments. And our plan is in that in the next 3 years, deploy about 10 to 15 units, and in 10 years, grow to about 100 units per year and about $150 million in annual revenue. An average system of us has a capacity of about 500 kilowatt, lasting about 10 hours per day on a daily cycle, and it will cost approximately $1.5 million. And that means for most customers, the return on investment is about 5 years or less on a system that will last 20 years or more with minimal O&M cost and with no need for replacement of parts. In terms of traction, we're currently in conversation with a few data centers, manufacturing facilities, and shipping and logistic companies to start a field test with them. Our plan is that by Q1 or early next year to finish our lab scale and raise our seed round and start our pilots phase. By Q3 2023, we plan to start our field installation and testing. By Q3 2024, we plan to finish the proof of concept and expand our pipeline. And by Q2 2025, we plan to finish testing, regulatory approval, and commissioning for commercialization and go out there for our Series A. Our team consists of seasoned and experienced individuals in their respective fields of engineering, operations, strategy, business development, investment, and product development. Together, we have raised more than $600 million and started, grown, and exited multiple companies. We're asking for $2.5 million for our seed round, which allows us to expand on the plan and execute on the milestones we just presented and get us to the next stage to go to market. Thank you very much for listening. Please, we're Volta Technique. Come and see us, and thank you to Rice Alliance.
Okay. Wow, this is really exciting. Hi, everyone. My name is Olivia, and I am with Woots. Every day, companies dedicate significant time and resources to push technology beyond the natural limits of conductive materials. Now, to break this costly cycle, we need the development of new materials that can do more. And this is where we come in. At Woots, we make carbon nanotube super materials that give your products a game-changing competitive advantage. If you are in the automotive, energy, power transmission, or defense industries, our cost-effective materials can open new frontiers in the design and performance of your products or those of your competitor. Now, to be very clear, we do not make raw carbon nanotubes. Rather, we translate their amazing nano properties to human scale.
skipping over the intricate details of our scalable, sustainable, and steady-state process, come Q2 of next year, our pilot line will produce commercial volumes of carbon nanotube fibers and film coatings that possess a unique combination of material properties hereto unseen. Take, for example, our fibers. Our fibers have a specific conductivity exceeding that of copper. They are also half the weight of aluminium. They are as strong as Kevlar, as flexible as thread, and they are stable in even the most aggressive of environments. In terms of commercial traction, we have contracted revenue in the tens of millions beginning in 2024, and we have multiple partnerships in the pipeline. By way of example, in partnership with Kuraha, a Japanese specialty products conglomerate, we are developing a novel piezoelectric wave energy harvester that will generate approximately 2.5 times more power per square meter than solar. Now, this highly efficient energy harvester is enabled due to our carbon nanotube film electrode. This is what I'm holding in my hand right now. Unlike traditional copper electrodes, which are prone to corrosion, are brittle, and are heavy, our electrodes are corrosion resistant. They are incredibly flexible. They are light yet strong, and they possess an incredibly high surface area to efficiently harvest the surface-bound charges generated by Kuraha's best-in-class piezoelectric material. It is not an exaggeration to say that Kuraha's determination to push the boundaries of what is possible through the use of our material could unlock the 32,000 terawatt potential of wave energy and revolutionize sustainable power generation in this country for years to come. And I recognize that wave energy harvesting may be a bit too blue ocean for many of the people in the audience today, okay? But we are in confidential discussions with partners for applications ranging from carbon nanotube RFID antennas to increase their toughness and their range, all the way to carbon nanotube fiber reinforced copper composites to increase the efficiency and performance of EV motors. Our materials are changing the rules of the game. So if you are in the automotive, energy, power transmission, or defense industries, and you are looking to increase your competitive advantage, or hell, even attempt the impossible, please reach out to us and let's talk. We absolutely cannot wait to leverage our technology platform to bring frontier-breaking design and performance to your business. Once again, my name is Olivia, and at Woots, we make the impossible possible with carbon nanotube super materials. Thank you so much for your time and attention, and thank you, Carrie, Matt, and Simone. We couldn't have done it without you. Thank you.
So Carrie said I had 52 seconds to share with you my emotional feelings about this program. And so I'm going to give you a brief version of it. 2 words, appreciate and accomplishments. So I appreciate what the program has done for me. I've been a mentor for 12 years, starting with the Houston Technology Center, and I think I'll be a much better mentor from working with the startups, working with the mentors, working with the program that we had, and I appreciate that. The other thing is that I am awed by these startups. They are moving so fast and accomplishing so much, I can barely keep up with what they're doing, let alone being able to offer suggestions of how to do better. Wow. The 3 in my pod all are really progressing so quickly. You grab them while you can. I'll let them tell you what they do.
Good afternoon, and thank you for the opportunity to present with you. The world is having large capacity wind turbine installation issues, but we have a solution. A seal is when we can lift any weight to any height without large capacity cranes. My name is Ken Johnson. I am co-founder and CEO of CLS Wind. And not only that, but we can actually do it with 30% savings, which on a conventional onshore farm of 75 units represents over $25 million. And we can do it 2 times or even faster. For the life cycle, that actually translates to double-digit savings, both onshore and offshore, which would actually mean tens or hundreds of millions of dollars in savings. And if we look at the market, and for us to reach our goals, our clean energy goals, we need to install between 10 to 20,000 wind turbines yearly until 2030 with a $20+ billion market. But we need to do it efficiently and cost effectively, and that is actually a problem. And regardless of whether you do it on an onshore setting, fixed offshore or floating offshore, you have to do it with large capacity cranes. And there's a huge problem there because all of them are reaching their limits. With the increase in size and heights of the wind turbines, there's a lack of long reach and heavy lift vessels and cranes around the world. In the offshore, for instance, the nacelle with the generator has grown up to 300 or more tons and heights over 120 meters. So it's very difficult to get large cranes that can actually do these installations. And they're very costly. But we have a solution. Our patented system can actually lift any weight to any height. A track is installed along the system, and a platform will lift the components to their final position. The tower sections are secure and supported vertically and horizontally. And our design is based on proven oil and gas lifting applications, so we're not reinventing the wheel. And because the components are loaded at a low position, we can actually use small capacity cranes, which are available everywhere, and they're very cost effective. The platform has a continuous motion, and we can actually lift the entire nacelle generator, plus the drivetrain, plus the hub in one single lift. And once the nacelle is in place, we will bring each blade one at a time to finalize the assembly. Also different from many of the other systems, the entire load path is along the rack, so we don't load the actual turbine, which is very important. And we can also work with any brand OEM. But of course, we're not the only game in town. If we look at the competitors, the cranes, which we already explained, there are actually other types, such as the climbing cranes and tower types developments. But because of their designs, they are actually very limited. Especially in lifting capacity, they're aiming to lift about 150 tons, while with our system, which is very different, we can lift 1,000 and more tons. If we compare an installation for a conventional system, you will need 1 large crane plus 2 small ones to put it together, a large pad, lots of transportation loads, and very expensive and environmental damage. With our system, it's only 1 crane, normal roads, 75% less loads, and we can expedite the farm completion. But another benefit is actually the offshore. We just completed a 15-megawatt feasibility offshore fixed study with great results. So we believe that we can use, with our system, some Jones Act compliance offshore barges and vessels that are available. To date, as I said, we have completed a 2.7 megawatt onshore system, our feasibility study for the offshore. We also have a new partner, an ESG company from Brazil, for development, and we're developing some additional IP. In summary, we can work onshore, offshore, no height or weight limitations, and great benefits and savings, and perform parallel installations. We're looking for strategic partners and investors to help us develop 2 things in 2023. One is a full-size commercial unit, and one is a scale pilot for the offshore unit. Please come to talk to us if you'd like to participate with us. And finally, I'd like to thank the Rise Alliance Clean Energy Accelerator, because you guys have been amazing, and again, we wouldn't be here without you. Also, Greentown Labs, our home, the ION for this opportunity, and to you for attending and helping us in this journey. Thank you.
Hello, I'm Matt Hogg, co-founder at Geogen Technologies, and we're taking old wells to make new energy. These are end-of-life oil wells. Currently liabilities transforming into geothermal assets. To do this, we needed a new model for geothermal based on kilowatts rather than megawatts. To make it profitable, we needed a technical breakthrough. We developed the Geogen cycle, a new thermodynamic process. From a high level, other geothermal is steam on surface making power. We use the liquid flowing down the well, much like a hydro dam, to generate power 8,000 feet below ground. The geothermal heat then vaporizes that fluid, causing it to return to surface, where it condenses and the cycle repeats. The impact is the well liability is deferred indefinitely, and it produces renewable baseload electricity with an LCOE target of 6 cents per kilowatt hour. Now, these old wells are everywhere. Take Huntington Beach in the 1920s. There are hundreds of communities across North America today just like this. And with Geogen, they represent the biggest untapped opportunity in energy transition investing. Trillions of dollars have been spent drilling millions of wells, and now we have to spend $300 billion cleaning them up. A single horizontal well can cost $150,000 to clean up, but with Geogen, it cash flows $150,000 per year. It does so by generating renewable baseload electricity. This complements wind and solar and competes with energy storage. Geothermal has never properly scaled, but Geogen is its best chance. We are able to alleviate any need for drilling. There's no exploration. Our projects are predictable, and now they're investable. Best part is our customers love it. We're deferring their wellbore liability, we're lowering their emissions, and increasing their netback per BOE. Again, this is different than other geothermal. The power is generated downhole and sent to surface via a wire. But the first thing we do with an old well is seal it shut. It's a closed loop system. We then create 2 flowing channels, one up and one down to circulate a refrigerant. This boils at the bottom and condenses on surface. The takeaway is that our design allows geothermal to be profitable where it never has been before. Each well produces 100 to 150 kilowatts of electricity, but there have been so many wells drilled, we're talking about gigawatts of electricity potential that can offset tens of millions of tons of CO2 annually. We're starting with the hottest wells first, but no well is safe. I just want to be clear, we are not taking over the wells. We sell geothermal conversions. The well owner gets electricity and carbon offsets, and we get paid on every install. By 2026, we will have the capacity to convert 100 wells per year, and by 2030, targeting 500 wells per year. We already have one well. It belongs to our partner, Spartan Delta. Through our ongoing demonstration project up in Canada, they will retain the well and become a geothermal operator for the first time. We see them as our prototypical client. We are raising our seed round, which will be matched at least 1-to-1 with grants in order to execute this demonstration project, build out our team as we seek to optimize certain components of our system, and develop our sales pipeline. We're changing the life cycle of a well, transforming liabilities into assets. The result is a decentralized energy resource made up of hundreds of thousands of repurposed wells. If you're interested in being part of our journey, please come find us after. I'd like to thank Rice for having us. Houston is the perfect place for this technology to flourish, and I'd like to really looking forward to being part of this for a long time. Thank you.
Hi, everyone. My name is Mary Beth Lundquist. I'm the COO of Eden. We break rocks with electric shocks. Eden provides electrical reservoir stimulation to maximize resource recovery. Our patented stimulation technology provides electric heating and electric shock between electrodes placed in 2 well bores to increase reservoir permeability. Electrical reservoir stimulation matches the performance of hydraulic fracturing at half the cost and requiring 80% less water. We can control the direction of permeability enhancement, allowing us to target specific zones for stimulation. We've been awarded a total of $8.2 million in DOE funding through ARPA-E grants for technology development because we need sustainable extraction of Earth's natural resources. This could be geothermal heat for power generation, oil and gas production, mining for critical minerals, or the emerging market of geologic hydrogen. Each of these industries have their unique challenges with permeability, and this is where we come in. Our diverse team brings experience from the oil and gas industry with backgrounds from ExxonMobil, Shell, and Schlumberger. Our MIT researchers bring expertise in fracture mechanics and numerical simulations. Our beachhead market is to deliver refrac services for the oil and gas industry. Unconventional wells experience high decline rates, which can be as high as 85% in 5 years. Frac jobs were not as optimized as they are today, which means volumes of resource can be left behind. And hydraulic fracturing is not efficient for restimulation, leaving operators no other option but costly plug and abandon and new well drilling to maintain production. We are fundamentally changing how operators approach depletion planning by enabling refrac. Electrical reservoir stimulation can restore declining wells back to economical production rates by accessing missed resource left behind by the original frac job. This allows operators to maximize their resource recovery and minimize their CapEx. Our business model is to be a technology service provider, delivering electrical reservoir stimulation for refrac jobs through strategic partnerships with existing oilfield service companies. To get here, we'll be demonstrating our technology in a series of pilot programs. Our equipment development timeline is shown here in dark blue. This year, we designed and built our downhole tool prototype and acquired small-scale DC power equipment. Over the next year, we'll be modifying our tool for smaller, cased, and horizontal wells. Additionally, we'll be building our custom pulse power device for electric shock stimulation and acquiring additional DC equipment for electric heating stimulation. Here's our team setting up and testing our power equipment in the field in preparation for our first pilot. We'll be executing our first of 3 paid pilots in January with Petroleum Development Oman, where we will be optimizing and confirming tool operations and DC stimulation operations. Now here's where you come in. We're seeking US-based pilot partners to confirm key aspects of our technology before scaling to a commercial demonstration. Specifically, we're looking for test sites available toward the end of 2023 with at least 2 wells, either vertical or deviated, in any reservoir lithology. Additionally, we're looking for some operational support for tool deployment. If you have a test site that would benefit from re-stimulation to increase production volumes, please come see us at our booth this afternoon. We'd love to have a conversation with you. We'll shock you. Let's break rocks together.
Hey everyone. My name is Deanna Zhang. I'm an XIR for this program. I'm a blogger, speaker, and advisor, and my blog is etechmonkey.com, so please follow it if you aren't already. It's been my great privilege to be an XIR for this program, for this cohort, and especially for these next 3 companies. I think I'll steal a line from Stephen earlier, was just to say that I've been in awe of all the accomplishments of this cohort. And in this pod alone, we've had a patent submitted, we've had an SBIR grant issued, we've had 3 to 4 new customers, and dozens of successful investor conversations. So what you're gonna hear is from 3 companies: Viridly, which is taking geothermal to the next level with a unique generator technology and a very novel business model. You're going to hear also from FuelX, which is commercializing Elaine, which is a solid-state hydrogen technology which can replace batteries. And then finally, last but not least, you'll hear from Decider, which is developing a new net zero planning software that can help companies evaluate new assets like geothermal and hydrogen. So without further ado, we'll start with Mei from Viridly.
Hi everyone, my name is Mei Pickering and I am co-founder and CEO of Viridly. We are a geothermal innovation company that is growing green energy by the power of heat. Viridly aims to disrupt the energy status quo with generator technology that is twice as efficient as current geothermal power plants, and it can generate electricity from untapped resources at lower temperatures. This synergy will enable transformative scaling of green baseload geothermal power for 4 cents per kilowatt hour. Current technology for most geothermal power plants is limited by inefficient organic Rankine cycle systems that are frequently overbuilt and underdeliver. The resulting slow returns on investment have prevented the industry from reaching scale. We are forced to rely on fossil fuels instead of clean geothermal power to meet our baseload energy needs. The US has over 4 terawatts of geothermal resource potential, but the US energy portfolio, but geothermal makes up less than 1% of the US energy portfolio. Innovation is needed to realize this potential. We are taking Stirling engine technology and modernizing it for the energy transition by configuring it into modular utility-scale power plants. Our proprietary Stirling power plants deliver 23 to 28% energy conversion efficiency, which is 2 times the efficiency of standard organic Rankine cycle systems, and they will lower the cost and time spent on maintenance. Our standardized modules prevent overbuilding and provide flexible generation capacity over the lifetime of the plant. This technology is also capable of generating electricity from lower temperature resources, unlocking access to vast, untapped potential. Viridly provides unmatched value and is transformative because of the impact it will have on multi-billion-dollar markets. Geothermal and waste heat resources from 120 to 250 degrees C account for 66% of total thermal energy resources, but they currently feed into less than 1% of the total power plant market. Viridly's Stirling power plants will unlock these resources and unleash explosive growth in these markets and in geothermal's share of the electric utilities market. Viridly filed its first patent and acquired geothermal leases in Nevada without financial assistance. With successful pre-seed funding, we will prepare to develop an upscaled prototype in 2024 and pursue our commercial demonstration project and first sales by 2027. And those first sales will make everything worth it. We expect revenue of $50 million from the sale of one 50 megawatt Stirling power plant and $27 million annually from our commercial demonstration project. We expect rapid growth to follow, with 2029 revenue reaching $100 million, and our vision includes expansion into an owner-operator business model. Our revenue forecast does not include the sale of carbon credits, but we expect to offset over 100 million metric tons of CO2 by 2050. My co-founder, Dave and George, and I form a complementary partnership built on resource extraction, engineering, and business expertise. We are assembling a solid team of advisors, and we will continue to expand our team this year. We are seeking pre-seed funding to double the efficiency of geothermal power, and we invite you to join us as we grow green energy by the power of heat.
As humans, we're born to move. That mobility comes with a cost. Fossil fuels, batteries, hydrogen fuel sources all have problems. Batteries are heavy, they degrade over time, and every once in a while they catch on fire. Hydrogen, while it's abundantly available, you need a heavy tank or pipeline to get it where you need it. It's been known to catch on fire or explode. FuelX makes a safe, portable, lightweight alternative. It's called Elaine. Solid-state hydrogen material that is perfect power source for things that move. Elaine is carbon-free power that is safe and convenient to handle and use. It operates at low pressure, doesn't blow up, degrade, or burn. It's not magic, but it is 5 times the energy density of lithium-ion batteries, and it's 2 times the energy density of high-pressure hydrogen. Elaine has been around for decades. The historical process required expensive aluminum as a raw material, and the process has been difficult to scale out of the laboratory. Other commercialization attempts have failed. This is where the FuelX team matters. These four founders form the core FuelX team. We have decades of experience in our field and are working together full-time to make FuelX a success. We are supported by key employees, diverse advisors, outside board members, and cooperative investors who are all engaged to make this company successful. We produce Elaine fuel using a proprietary process that combines hydrogen and aluminum without consuming lithium. This is a big deal. No one else can do this. FuelX has the process that makes Elaine economical and scalable. The Elaine powder is compressed and stored in lightweight cartridges. The second part of our solution converts the stored hydrogen in the Elaine into electricity. The Elaine system uses an Elaine cartridge instead of a high-pressure hydrogen tank to supply hydrogen to a standard fuel cell. This works with any hydrogen fuel cell. Our controller manages the hydrogen released from the Elaine. The fuel cell converts it into electricity. These lightweight power systems are perfect for things on the move. Things that move create Elaine opportunities: trucks, planes, people, and more. The Army has spent over a decade evaluating battery alternatives to lighten the load on our soldiers in the field. Elaine power systems reduce their carried energy weight by 80%. We have received 3 Department of Defense grants to date, and we have an Army contract to produce these systems and supply the fuel to the Army. We've also reached an agreement with Piasecki Aircraft to develop and flight test our system to demonstrate its superior safety and operability over explosive high-pressure hydrogen. We began this journey 4 years ago. We produced the first batch of Elaine in our laboratories in April of this year. It puts us on track to deliver MVPs early in 2023. From there, we anticipate a fast ramp to commercial volume to meet the Army and airplane contracts we have in place. To generate revenue, we will design, build, and sell Elaine power systems, followed by recurring revenue from the 100% recyclable and reusable Elaine fuel cartridges. We have a 100% domestic supply chain. We'll break even in 2025. We are currently raising a $2 million final seed round to complete our Elaine production and systems MVP milestones. Note that to date, 75% of our funding has been raised through non-dilutive government grants, and we will continue to pursue funding through our good relationships with them. In summary, there are 3 key takeaways. FuelX has solved the scale and cost challenges that have held Elaine back. The Army and the broader mobility market are demanding safer, higher energy density fuel systems. And third, the FuelX team is uniquely qualified to deliver Elaine power systems to the market at scale. And finally, as my fellow founders and most of the mentors have pointed out, sometimes many times, my presentations are not exciting. Do not be fooled. I may not be exciting, but I am excited about the future of Elaine and FuelX. Stop by upstairs and let's talk about it. I'm Greg Jarvie, co-founder and CEO of FuelX.
Good afternoon. I'm Sujata Kumar, founder and CEO of Decider. Although I have run multiple tech companies, Decider is a special journey for me. Sure, the cause is important, but I've also personally experienced the challenges of net zero planning, working with energy companies. So we assembled a stellar team and built a disruptive product to solve these challenges. Excited to share Decider with you today. So what are net zero challenges? Let's see that through the lens of Harold. He works for a global energy company and is tasked to analyze cross-asset portfolio of assets for renewable energy. What you see in front of you is a mess of a process Harold and his team have to go through every single day for a single analysis. I'm sure there are Harolds in this room today. You surely have Harolds in your companies. I myself have walked in his shoes. It is a complex and time-consuming process that takes 6+ months for just a single analysis. So why is that? Because Harold and his team have to pull data from multiple sources and do complex computations in Excel, and then collaborate with multiple stakeholders and pull that data in to do further analysis, guess what, also in Excel. Energy and chemical companies spend 48 million hours annually on these analyses. That is a $5 billion problem that is growing and delays action towards carbon reduction goals. We created Decider to simplify these analyses. We embed these complexities and deep domain knowledge into our models so Harold can do his analysis in hours versus months. That is a 100x acceleration in planning, delivering $100 million of savings for companies. So how do we do it? Our plug-and-play SaaS solution allows companies to bring in their data, configure our objects, use our computation, or build their own, leverage our models, or build their own, all while collaborating in real time to do scenario analysis to understand clear trade-offs. This is net zero planning, and we simplify it for companies. We've created a single platform for analysis from planning to operations, providing companies the ability to do risk analysis while creating transparency in decisions. We are operating in a $60 billion market, but we are focused on energy and chemical companies in North America. That is a $1 billion opportunity in itself. Our go-to-market is phased. We have ongoing pilots with Fortune 100 companies. We are leveraging the learnings to enhance our product. Our phase 2 is about delivering a game-changing self-serve platform that allows us to rapidly expand within the current market while setting us up for rapid growth in adjacent markets in phase 3. We have current traction with models such as hydrogen, geothermal, and CCUS, while we are growing a diverse pipeline of customers and use cases. We are targeting 47 million in 2027. Our competition, we are the only net zero planning platform in the market today. We have embedded our knowledge into our models, but we integrate data from other sources, such as footprints, emissions, and real-time data from customers to provide that holistic analysis for Harold and his team. Our ask today, we are launching 3 pilots next year, and we want to talk to you. We are also raising a seed round for $3 million to do that game-changing self-serve platform and to expand our team and grow our pipeline to reach that $1 million ARR. Thank you for your time. I'm Sujata Kumar. Harold needs to be net zero. Harold needs to be net zero faster with Decider. Thank you very much for your time.
Well, good afternoon. I'm Mike Evans. I'm also an XIR here with the program. This is my second term at doing this. Carrie keeps hoping I'll learn how to do it if she keeps inviting me back. But why did I only get 50 seconds and he got 58 seconds? That's what I want to know. It's been my great pleasure to work with these next 3 companies you're going to hear from, and they are the last 3 companies, by the way. These companies are each in a different place in their journey, ranging from where they are in product development to funding to commercialization. The first company, NobleWorks, is doing research and development on a supersonic combustor can for gas turbines, leading to great fuel savings. Supersonic combustor can, that's got to be high tech, right? The second company, Pressure Corp, is using off-the-shelf products to present a turnkey solution to gas pipelines at letdown stations to recover the energy from that pressure drop. The third company, Nanotech, is using a nanoparticle-based spray-on solution that you can coat a roof with. It results in 50% heat load change for that building. That goes on forever. So these companies have a lot of places to go. They have tremendous bottom line impact on their customers, as well as very significant ESG benefits. With that, I'd like to bring up James Villarreal of Noble Works.
Thank you, Dr. Evans. Hi, my name is James, and I make fire for a living. So today, our world is completely, and I mean completely, dependent on the combustion of fossil fuels. And that is not going away anytime soon. By about 2050, we're going to see a 50% increase in global energy demand, so that pie gets larger. Renewables are not keeping pace, so even that new energy demand is going to be met by combustion of even more fossil fuels. But the good news is we can do better with what we have. So at Noble, we've developed a new type of system that is 25% more fuel efficient. That means up to a 25% reduction in cost, and then a commensurate reduction, a 25% reduction in CO2 emissions. So our technology is called rotating detonation engines, but I really like to think about it as supersonic combustion. So anything, really, planes, trains, automobiles, it all relies on subsonic combustion. But what we do differently is we use the exact same fuels, and then we hit it tangentially with a shock wave, and then that supersonically combusts the fuel, and it keeps moving around, ingesting that fuel in there. So if you're looking at that timestamp, it's something about 4,000 times a second it's going around that annular chamber. So this is how it would look like inside of a combustor, inside of a turbine. And first of all, we are not building turbines from scratch. We're not trying to build new turbines from scratch. What we are doing is upgrading the very heart of those systems, which is the combustor. Now, these combustors, they're replaced every 5 years or so anyways because they burn out. So we're building a drop-in replacement for that using our supersonic combustion technology that will then save it fuel in either new turbines or in existing turbines. So if you look at the market, it's pretty huge, anything that burns fuels. But here I'm just taking a kind of a look at the gas-fired power plants. And the money that you really care about here is really the operations and maintenance costs, which is what you would use to replace the combustors in the first place. Worldwide, that's about $64 billion a year. And even if you dive down into a small beachhead turbine, that's about $500 million a year. So this is a really, really, really big market. If you like pie charts, we're that little blue sliver on the entire side of that. So if you Google this technology right now, you're going to find that it lives mostly in aerospace and defense, and that's where we come from. So we have over 100 years of aerospace and defense spanning a lot of functions, going from sketch on a napkin all the way to building and running factories. So we've done this before. We've been there. We've run billion-dollar product lines and thousands of people, and we are excited to do it again, but with energy. So in terms of traction, we have a few contracts right now. Shell is one of them. Hi, Matt, he's here today. And also US Air Force. So for Shell, we're using our engines with hydrogen because our engines work particularly well with hydrogen. So that's a fun place for us. And then US Air Force working on ramjet and scramjet technology. In terms of technical traction, we are building and firing and testing, and it is a lot of fun, our hardware every single day, increasing the technology readiness level of the system and the subsystems, and then filing patents, getting intellectual property. And then probably the most important competitive advantage we have here is that we are first, #first, company exclusively focused on detonation engine technologies. So with that said, here's our roadmap, about a 5-year roadmap. We have a nice pipeline right now of development contracts. We're going to keep growing that. But sometime next year, we need to start stepping into putting this technology into an actual turbine. So that'll happen midway through next year. And then we'll qualify that and go into product bookings and sales. Of course, that takes money. So we continue to grow our development contract pipeline with both energy and defense. And then looking at a seed round sometime in the middle of next year. So with that said, really, we're looking for design partners. We're looking for partners with deep energy experience that can help us take this technology, navigate, and introduce it into larger energy markets and gas-fired turbines around the world. And with that said, thank you to Rice. Thank you for taking a chance on some recovering rocket motor guys, inviting us here.
Good afternoon. Thanks for the opportunity. Grateful to be here. Thanks to Rice and all the sponsors beforehand. What a great experience. My goal today is to connect with companies in the audience that own and operate pipelines. And, so don't fall asleep if you don't own a pipeline, investors who understand the value of a Ready Now ESG solution that is also economically accretive to its customers. My name is John Happ. I'm the CEO of Pressure Corp, and we make clean power out of waste pressure. So why would customers want what we're offering, and why would you want to invest? Our customers are excited to find a Ready Now ESG solution that can be deployed natively on their system. Pressure Corp's solution offers just that, providing inexpensive, zero-carbon power that competes with solar with the added benefit of no CapEx burden from the host customer. We're cost-free and hassle-free. We finance, construct, own, and operate and create clean energy credits for our customers. We're a full-service provider. Pressure Corp, so how do we do it? Oh, sorry, back one. So how do we do it? We employ turbo expander technology at letdown stations on pipelines to provide zero carbon, baseload clean energy, direct cooling, the creation of ITCs and emission credits for our customers. We're a tangible ESG solution that has net zero impact on the host customers' budgets. I know we're not cracking atoms here like a lot of the folks you heard from today. Our turbo expander and electric turbine technology is TRL9. That means it's ready for scalable deployment now. It's the pipeline application that is novel in this case, as well as our complete ESG solution that we hand over with a bow to our customers. In your mind's eye, picture a pipeline that starts off at 1,200 PSI, and as it gets to the delivery area, even as natural pressure drop occurs, you're still at 600 pounds. But the customer can only take it at 300 pounds. We take that 300 pounds of waste pressure and turn that into clean baseload energy for our customers. So who are our customers? They're local distribution companies. There are 30,000 delivery points in the United States alone. This works very well in front of gas plants, which there are 2,000 in the United States, and over 9,000 delivery for long-haul pipelines, and a staggering 180,000 industrial customers that have gas as their feedstock. We create scope 1 and 2 emissions for our customers, low-cost green power that competes with solar, which we have a 15 to 20-year PPA, which that's how Pressure Corp makes its return. We qualify customers for the ITC and energy credits. We're TRL9, which means ready now, and the customer enjoys a very safe and reliable service with no business interruption. If you're aware of the term, they own the slam valve. So why would you back us? Every team member at Pressure Corp has over 10 years of energy, environmental, and legislative experience. Sadly, in my case, many more years than that. My last post as Chief Commercial Officer at South Cross, we sold to Target earlier this year. I've been a part of 3 management teams with 3 successful company sales, built hundreds of miles of pipeline, 2 crude terminals, and 2 cryogenic gas plants. I owned and operate and sold a physical oil and gas trading company in 2008. And we did one very esoteric thing there. We traded emissions, lots of emissions. So our investment ask today is a $5 million pre-money safe with a $20 million valuation. This $5 million funds our first CapEx deployment, and all subsequent projects are debt financed. That's very important. And it also provides 2 years of G&A runway. So see some of our traction today. Today we have a large project queue or pipeline of potential customers, forgive the pun. There are just a few that are in advanced stages of negotiation. We have 2 LOIs and are passing definitive paper in the form of PPAs with 2 others. For color, if these 6 projects alone were the only ones to be deployed in 2 years, Pressure Corp would have an $80 million operation at 5 times EBITDA. There is a huge market to deploy this technology and provide host customers with an ESG solution that requires no capital CapEx from the host customer and is economically accretive to them. Thank you again for the opportunity.
Hi, everybody. My name is Mike Francis. I'm the co-founder and CEO of Nanotech, and I stop fires for a living. Nanotech started out of a garage right here in Houston, Texas. We sold our first batch, blended right out of my own beer tanks. Thanks to our friends at Halliburton Labs, we have scaled up from the beer tanks and are currently producing thousands of gallons of our product today. We're solving 2 grand challenges. The first is related around carbon emissions. 40% of all US CO2 emissions result from the demand for heating, cooling, and hot water in buildings. We can tackle that. HVAC systems use about 48% of a building's energy on average. The second problem that we're tackling is we want to fireproof the world, starting in fire-prone states such as California and Colorado, where we are actively passing tests and going on infrastructure as we speak. So what is it that we do? We have developed a particle, and by we, I mean our really smart chief scientist, has developed a particle which can be embedded into many, many different materials. Paints, polymers, resins, composites, cement. When it's embedded into cement, it makes the cement about 10 times more insulating. We have two flagship products. One that you're seeing here is our fireproof coating. Our fireproof coating will fireproof to about 1800 degrees Celsius. There's no chemical reaction, which means there's no smoke, no flame spread. It's sprayable, no VOCs, and it'll continue to protect the building or the structure. It's not dependent on time. The way that it works is it has two key properties. One, it has what's called a perfect emissivity. It's the only coating in the world that we know of that has a perfect emissivity. That means it's emitting the heat away from the substrate. The second property it possesses, it has a very low thermal conductivity. Thermal conductivity is just the resistance of heat. Our particle and our material is actually less thermally conductive than what NASA uses on their reentry programs. It allows us to fireproof at extreme temperatures and also create thermal isolation in buildings, heat exchangers, and more. My kids are in the background of this video saying, "Put your hand under it, Dad," so I had to do it. Our flagship market is actually the roofing market. We said, how can we take our particle, adapt it for a roofing application, and go to scale? We're currently on dozens and dozens of roofs all across the US. In fact, we're on about 15 or so Domino's pizzas where we've been able to drop the temperature inside by about 30 degrees. On many of our case studies and pilots, we're actually dropping the temperature or the HVAC consumption between 35 and 50%. This is our coating in action here in Houston. You can see that it is coated and it's showing at about 95 degrees. That's right at about ambient. When you go to the uncoated side, you can see that it goes from 95 degrees to 165 degrees. We are pitching sustainability with a return in a new category where we combine fireproofing and thermal protection. For my customers in the room, I am not dropping my prices, but I do have an 86% gross margin. We are currently raising a Series A of $25 million, of which $15 million is already committed. Come see us upstairs and see more fireproofing videos. Thank you so much, and let's make Houston Launch City.
Congratulations, Class 2. I don't know about y'all, or all y'all, as we would say, but I'm breathing much easier right now. So I'm super amazed by the progress that you've made. We all are, Matt, Simone, the whole team. You guys have been a privilege to work with. We were so pleased that you joined us this year. Executives and residents couldn't have done it without you. Thank you so much for your leadership and guidance. We're just really excited, but your journey doesn't end today, and your engagement with us doesn't end today. So the Rice Alliance will be here to help you going forward. To the extent that we're able to help you, we're happy to do that. So please remember you're part of a much larger family now. So welcome to the Rice Alliance family. To the audience, keep in mind their work doesn't end today either. We invite you to stick around and go to the showcase, visit their showcase booths, and explore ways that you can help them achieve their next near-term milestones. All of them had asks. Hopefully there's some that resonated with you that you would be able to help. And if you are a clean energy entrepreneur in the audience thinking that you have something that could enable or enhance the energy transition, and you think that this program is something that would align with the goals that you have in mind, please reach out to me or Matt or Simone and let us know about that interest, and we'd love to learn more. But with that, that closes Class 2 of the Clean Energy Accelerator. I invite you all to stick around to join us at the showcase. Congratulations, everybody. Cheers.